Okay, last day of notes before we take a quiz on Monday. Tomorrow we're basically just reviewing, so you don't have to worry about learning anything new tomorrow. Remember, this is, well, don't say remember. I guess I should start this. We're going to go to Desmos and play around with some functions. Let's say, I wonder if I could skip that for right now, but if you're absent, I can't skip that because it's pretty cool. Let me just show you. And pretty much, if you're listening to this, if you're listening to it to understand what we were doing better, then you go to Desmos and play around with this. If you're absent, same thing. You go to Desmos and play with this. So it's desmos.com, desmos.com. Click the graphing calculator, and then just pick a function. Like, just do the absolute value function. And pull up the keyboard down here. And there's the absolute values. We'll put an X in there. So I just suggest leave that on there, and it'll tell you what color it is. That one's red. Okay, then just play around with the numbers. Like, if you put a -3 out front. Oops, where's the absolute value? Oh, there it is. Oh, hang on. There we go. Oh, look, it made it, stretched it vertically and flipped it upside down. And then what if we stick a +2 on the end? Oh, it moved it up 2. Then if we come in there where the X is and put a -4, it's going to move it 4 to the right. So if you are at home, just go to Desmos, play around the numbers, figure out, okay, here's what I think it's going to do. See if it actually does it. Okay. All right. So back over here, we're going to look at all the ones you have to know. There's a few of the transformations you don't have to know for the quiz. Horizontal and vertical translations for sure. So just remember, if you want to move something sideways, like say you start out with some function, you put a number in with the X. And that's going to make it move sideways. If whatever number you put right there, it says -3, -7, that's going to move it 3 to the right, 7 to the right. If you put the H part of it's negative, so like say you did X minus -2, that turns it into X plus 2. That's going to move it 2 places to the left. Okay, so just remember that. And then if you want to move something up and down, take the function and just add some number to the end. So if that number that you add is a positive, it'll move up. That number that you add is a negative, it'll move down. Okay, so here's where you really kind of just show that you understand this. Okay, don't worry about what the function is for just a second. There's some function. We're going to come up with a new function. We're going to call it G, that just translates it 3 units down. So it's basically just realizing, okay, whatever the function was before, subtract 3 from it, because that will move it 3 places down. And then now pay attention to what the function was. Your function was 2x plus 1. So if you clean up what that function looks like, you'll get y equals 2x minus 2. Okay, same deal. It's just a linear function. Don't worry about it. Write a function h, whose graph is a translation of 2 units to the left of function f. So take function f. If I want to go 2 to the left, then wherever the x is, it's going to say x plus 2. So if I go back and look at my function, I'm going to put the x plus 2 in where the x goes. So this function that will look just like this one but move 2 units to the left will be 2x plus 5. Okay. And if you want to, you can go to Desmos and check and see if that's true. You can graph this and see if one of them is just 3 units down from the other one. Okay. All right. Now reflections. This is the one that you have to know. We're going to reflect about the x-axis. This one, we're going to hold off till pre-cal. But what I am going to do, there is a bonus on the quiz on Monday. And I didn't care for the bonus that everybody else is using. So I'm going to change it to being a bonus about the 2 things we don't do. So I'm going to make, probably, I guess tonight I'll make it. I'm going to make a little video of explaining how to do reflections in the y-axis and reflections in the x-axis. Sorry, reflections in the y-axis and horizontal stretches and compressions. So, if you're interested in getting the bonus, then you're going to want to watch that and make it make sense, and then maybe you can get the bonus. If you could care less about a bonus question, then you're not going to watch that tomorrow. So just know that's what's going to happen. So you've got to know reflections about the x-axis. So again, it's an absolute value function. Let's just ignore it for a second. Write a function g whose graph is a reflection in the x-axis of the graph. Remember what we were talking about the other day? You just want to take all the answers you did have and you flip them over the x-axis. That means you're going to do the opposite of whatever that function is. Okay? So if we want this new function to reflect about the x-axis, we want the opposite of whatever f of x was. Okay? And f of x was this. So what I want is the opposite of the absolute value of x plus the quantity x plus 3 plus 1. So you're doing the opposite of all that. So it's the opposite of the absolute value minus 1. And that's our new function. Okay, now the B part right there, that is going to be something I do on the notes about the folks who were concerned about the bonus question. Okay, horizontal stretches and shrinks, nope, save that for pre-cal. But again, I will explain it in the extra video that I make it if you're interested in the bonus question. You've got to know vertical stretches and shrinks. And again, I know everybody here calls it a shrink, and the book we're using calls it a shrink. Most books call it a compression. So I just don't want it to show up on the ACT and they say compression and you have no idea what it is. You're compressing it, you're shrinking it. All right, so same deal. We got some absolute value function. Don't worry about what the equation is for just a second. This one's asking about a horizontal shrink, so we're not going to do it. This one's asking about a vertical stretch. That's the one we're going to do. So we're going to make this new function, h of x, and we're going to stretch it vertically by a factor of 2. So we want all the answers, whatever f of x was, to be twice as high. Oops, I don't have to write that until the end. Now let's look and see what it was. So twice that f of x. There's our equation. Okay. And again, if you want to make sure you're right, we could go to Desmos and look at the two of them together. Example 4, let's see what we're doing here. Write a function g whose graph represents the indicated transformation of the graph of f. So we're going to take this, move 6 units down. So we're going to take that function and move it 6 units down, and we're going to call it g. So g of x will be the function that we've got right now, moved 6 units down. Oops. Well, yeah, I was going to say, is it going to take more than 1 step? -1 minus 6, that's just -7. Nope. Okay. This one, we want to translate something 7 units to the left. So again, don't worry about f of x. That means we're going to have this new function. And if I go 7 to the left, that means I've got to put an x plus 7 in where the x is. So our new function will be this. Okay. Like something about the x-axis, you just want the opposite of the function that you have now. You want all the y values to be the opposite. So this new function will be the opposite of the function we have now. Okay, we're going to shrink it vertically. Take the function you got now, shrink it vertically by a factor of a fifth. That means it's a fifth as high. That's your new function. So that g of x is a fifth of the function we have now, which is that. And stretch it vertically by a factor of 4. That means take the function you got now times all those y's by 4. So our new function is 4 times the current function. And then you're good. Okay, one more example. We're going to start out with this. Okay, let's start out with this absolute value. That's f of x. Okay, and it's going to go through points like 2, 2, and -3, +3. Okay, right there, 0, 0. First, write a function g whose graph represents, well, I said first because I kind of knew, I remembered what I typed up a couple days ago. Write a function g whose graph represents a reflection of the x-axis, followed by a vertical stretch by a factor of 3, followed by a translation 5 units down. So it's like we're just going to do this in order. Okay, so we'll start out. First, we're going to reflect it over the x-axis. And you don't have to do the graph at all. I just want you to see what's happening. So that's going to flip it. So let's call that one, because they want the answer to this to be g of x, so let's just call this. If I flip it over the x-axis, it's the opposite of what it was a second ago. So that gets me to there. Okay, then stretch it vertically by a factor of 3. So we're going to take that graph and let's call it j of x or something. Just pick some other letter. We're going to take the function we have now, multiply all those y values times 3. So now we're to here. Oops. Okay, and if you graphed it, that would just make that absolute value not rise this time around because we're going down because we already flipped it lower a lot quicker, so it'd make it skinnier. Then translate it 5 units down. So if and they said the final answer was g of x. So we're going to take the last way we wrote it and move it down 5 units. And then we have it.